Welcome to Study Loop.
An insect can be considered as a regular thermodynamic body which obeys the first law of thermodynamics. So the heat released is equal to the change in internal energy plus the work done by the insect. So we'll consider the insect as any other thermodynamic body. Q equals delta U plus W. So now here we should make some important substitutions. The overall Q can be is equal to the mass of the insect times its heat capacity times the change in temperature. Then the change in internal energy can be substituted to be equal, in cases like this, to the mass times L. And also the work done can be expressed as equivalent of the kinetic energy of that is going out of the insect's body and is doing work on the surroundings. So this is for mechanics, and this will be equal to the work done equals 1/2 mass times velocity squared. Plugging all of these substitutions into first law of thermodynamics, we obtain the next form, the equation, and Ci delta T equals mL. And remember that we need to solve for L, for this specific joules per kilograms ratio. L plus 1/2 mass times velocity squared. So simply we will move this part to the right-hand side, to the left-hand side, and then to the right-hand side. And then we will divide all of it with this term to have this term alone on the left-hand side. When we do these algebraic transformations, we obtain that L equals Ci delta T minus 1/2 velocity squared. We lose mass as a variable, and that is a very important part of this solution. You don't need to worry about the mass for the final solution. Then we can substitute the rest of the values which are given in the problem. So this will be 4.19 times 10 to the third power, and this will be in joules per kilogram Celsius. We'll use Celsius degrees here, and this will be 100 degrees Celsius minus 20 degrees Celsius, and then minus 1/2 19 times 19 meters. This is going to be squared. 19 squared, meters squared, seconds squared. Now, don't worry about use of the Celsius degrees because they will cancel out here and here. So we will be left with joules, kilograms, meters, and seconds, and we obtain the final answer in SI unit system. When we place these values into a calculator, we obtain that L equals 3.35 times 10 to the fifth power joules per kilograms. And this is the final answer for this problem. I hope you find this helpful, and I hope to see you in another lesson.